Welcome to Around Space. I'm Kent Miller. Today we'll be talking about songs about kids in space. I'm delighted to have with us Jim Thorne, space scientist and singer-songwriter. As for his space science background, in 1984 he got his Bachelor of Science in Astronautical Engineering from Purdue University. He then joined the U.S. Air Force as a second lieutenant. In 1996, he got his PhD, also in astronautical engineering, this time from the U.S. Air Force Institute of Technology at the Wright-Patterson Air Force Base in Dayton, Ohio. In 2005, he retired from the U.S. Air Force as a lieutenant colonel. Now, as for music, he's been interested in, he's been performing since he was a child, and he's been writing since high school. In 2014, he was contacted by a talent agent who had seen some of his family-friendly comedy songs and wanted to know if he could write for children. Welcome to this show.
Thank you very much.
First, tell us about the CD that you have just brought out.
I just recorded a CD called To Follow Apollo. It has 7 songs that are about kids going into space. And there are 2 characters, a boy and a girl named Tommy and Laura. I've tried to include them in each of the songs so that they can go on an arc of adventures. One of the stories has them going back to the moon to find the Apollo landing sites and to continue on further to the 3 additional landing sites that Apollo would have gone to had it not been canceled early.
What instruments do you play?
I play the guitar. On this particular CD, I use either 6 or 12 string guitars depending on the song, and beyond that I play the flute, and I play, it's been a long time, but I play some brass and a little bit of keyboard, but primarily now it's guitar, flute, and vocals.
So that was in high school and college?
Yes, that's right.
Right. When did you start writing?
I started writing songs in college. I figured no one had to hear them but me. I was a little shy about it, so I wrote and played them for myself. And then when I started to teach some basic guitar for some friends, at one point I worked up the courage to mention that I'd written some original songs. And of course they wanted to hear them, so I ended up playing for them and for some, what we would now call an open mic show at Purdue University.
Now your music style is, I think, from an era where we grew up.
Yes, it's very much folk style. I was heavily influenced by John Denver and Jim Croce, James Taylor. I learned to fingerpick the guitar by listening to my sister's John Denver records. She got to see him live. I never did. I wish I had. But I really enjoyed his music, and I liked the clear storytelling that one can do with that style of folk music.
Yeah, that's wonderful to grow up with that kind of music. Let's see, you perform for local schools.
Yes, I do. I have a number of friends who are teachers in local schools here in Northern Virginia. I did get to go to one school in New York City, an all-boys school. And what I do there is I use the music just as an introduction. Then I give them a presentation of a series of, you could call them trivia questions, I suppose, but they're physics questions about the planets and rockets and gravity and that sort of thing. And what I've learned to do is to phrase them as yes or no questions, and then I have the children vote whether they think it's yes or no, and then I never put any one child on the spot, which works much better. And that's been a very smooth way to handle it. And usually the teachers will vote on the answers too. Then they're so engaged that they're just waiting for me to give the scientific reveal at the end of that. Then at the end of the program, I will do another sing-along song, which I'll teach to them, at least for the chorus, and they'll sing with me. I have one more school assembly coming up this coming week at Greenbrier East Elementary School in Fairfax.
Now, at the moment, this is June.
Yes.
I don't recall when schools get out.
Well, it turns out it's June the 22nd that I am scheduled, which is the day before their last day.
Oh, okay.
So I will be some form of entertainment, I suppose.
Well, that's a treat for the children.
I hope so, yes.
Excellent. How is this arranged? Is there an agency that schedules these things? Or?
Not so far. It's been word of mouth. I have a number of friends through the local music community. I am a member of the board of the Songwriters Association of Washington, and that has allowed me to contact a number of folks, some of whom are teachers or they know teachers, or sometimes at work there will be parents who know what I do, and then they will contact their children's teacher, and it works like that. So I have not formalized this in any way, but I really enjoy it, and it's about once a month on average that it's been working out.
Right. What do children ask you?
They have asked me so many interesting questions. It's clear they've been influenced by the media,
I guess.
the movies and so on. So I will almost always get a question about black holes. I got a question once about Stephen Hawking.
Okay.
I get asked, let's see, are there aliens? They always want to know that. And they've asked me if I have ever been in space.
Okay. Which I take it not, yeah.
I'm sorry?
You haven't been to space?
I have not been in space myself, but I like to tell them that my name is on Mars.
Oh, okay.
And they find that surprising, and then I explain, I was an exchange scientist briefly when I was at the Air Force Research Laboratory. I was assigned briefly to the Jet Propulsion Laboratory at Caltech, working on a nuclear-powered spacecraft to go to Jupiter that was canceled. It was called the Jupiter Icy Moons Orbiter. While I was there,
JIMO, I remember
JIMO,
that.
yes.
I remember that, yeah.
And the nuclear reactor was going to be called Prometheus.
Okay.
It was a very interesting project.
Yeah.
In any case, it was either that trip or one of the others to JPL. I got to sign the logbook at the clean room where they were assembling the Mars Curiosity rover. So my name is one of a large number, but still it got scanned and presumably was loaded into memory onto the rover. So yes, my name, I believe, is on is on the surface of another planet.
So it's one of those two rovers that were traveling around for several years.
Actually, it's not. It's not one of those. It's the newer one. It's Curiosity, the one that's nuclear powered.
Oh, I see. And the others are solar cells.
Spirit and Opportunity were solar powered. Yes.
Right. Yeah.
And one of them is still operating, as I recall.
Okay. Now you earlier in your career did some research.
Yes, in grad school. I. As an undergrad at Purdue, I had a wonderful professor who I will go ahead and name. Her name is Dr. Kathleen Howell, and if she sees this, I'm saying hello. I was in one of her first classes, and during that class, we did a simulated mission to visit two asteroids named Pallas and Juno, the real asteroids, and we had a 7-year window in our hypothetical spacecraft to go to one, do a maneuver, and then do a flyby of the other within this 7-year period. And the question was, how does one minimize the total delta V, or the amount of fuel necessary to accomplish this mission? And in order to do that, from a mission planning standpoint, one has to solve something called the Lambert problem repeatedly. While I was looking at this, I thought there must be a direct solution to that problem, because it's just basically one input and one output.
Right.
So I drew a graph using a French curve, because it was so long ago. We didn't have, but I had drafting, as in with a pencil, when I was an engineering student at Purdue all those years ago. So I drew this curve, and I thought, well, that looks like it could be a power series with an inverse term. So I guessed that, and then was able during my master's program to prove that that was indeed the form of the solution. And a gentleman named Richard Batten, who has since passed on, but was a teacher for many years, professor at MIT, taught such notable folks such as Buzz Aldrin, about orbit mechanics. I got to meet him eventually, because he had said in his book that it wasn't possible to solve the problem that way, but I didn't know that when I was trying things. And eventually he came to a conference where I gave a paper, and we became friends, and he congratulated me on this. And I'm very honored to have gotten to meet him. Just by means of background, he programmed the onboard computers for the Apollo program.
Oh my.
Yes.
Okay. That's long ago.
Yes, yes.
Yeah. You did something with electrical propulsion.
Yes, as a doctoral student, I looked at optimal control. If one assumes that you do have a functioning continuous thrust, then how should it be steered over time to change from one orbit to another in the minimum amount of time using Euler-Lagrange theory? That uses adjoint variables, and the physical conditions do not give you the initial values of what those should be. So traditionally one had to guess what they are. I found an approximation that could be solved in closed form to get formulas for what those initial values should be, and then using something called a continuation method, you can approach the exact case that you need, and that was successful. I was able to do that for a number of programs, including GMO.
It's an iterative solution?
It is an iterative solution, yes.
You get closer and closer to the exact solution.
But the assumption is that the initial values are good enough to get initial closure that one can then walk from iteratively toward the desired condition.
Oh, pretty good.
Yes, another lucky moment there where something just worked out.
Yeah. You mentioned earlier nuclear power.
Yes.
Or space nuclear power. Yeah.
There's a lot of interest in that, of course, because if one wants to send a probe beyond, say, the orbit of Jupiter at 5 astronomical units, the amount of sunlight decreases quickly, at least inverse square, if not worse, depending
on. It's like 1/30 of here. Yeah.
There's currently a mission to Jupiter called Juno that is supposed to do its orbit insertion on the 4th of July. So I'm waiting with breathless anticipation, as I'm sure anyone at NASA working on it is as well, because it's going to be a very lengthy burn, and that's always a tense moment in a program.
Yeah.
So in that case, they used very large solar panels, but that's about the limit of what one can do, and that's at Jupiter. If you wanted to go to Saturn or beyond, really nuclear power is the way one would need to do it. And by that I mean a reactor, not just a radioisotope thermal generators such as Voyager uses. It's a very small amount of power for those, but you would need a larger reactor if you wanted to have a powerful radar to penetrate, say, the surface of a moon.
Right. Now, if all you had to do is keep the electronics warm, then a
RTG.
radioisotope thermal generator would be adequate.
Yes, it would.
But here you have some more powerful equipment that
for sensing and sure.
Yeah.
And also possibly propulsion, as we were just talking about. One might use that for electric propulsion to allow, for instance, to go into orbit around Pluto. I had people asking me not too long ago, why did New Horizons just fly on past Pluto, take pictures really quickly, and then on its way? It's because it would take an enormous amount of change of velocity or fuel in order to stay at Pluto, because it was going so fast. It was either 14 or 16 kilometers per second. I mean, it was very fast.
Tremendous, yeah.
But if one were to use electric propulsion so that you're braking, accelerating and braking, then one could still get there in a reasonable time, but match and rendezvous the conditions at the planet and perhaps stay at Pluto and take more pictures.
Yeah. There's Pluto and its companion Charon are truly interesting, and they're not the same. They're very different.
Yes.
We sort of assume that they would be similar, but they're not.
I'm not sure. It was so interesting to see this Tombaugh region shaped like a heart on there.
Yeah.
But a good friend of mine in the space business told me years ago that every time we go and look somewhere where we have not been, we're always surprised. There's always something new that's there.
Yeah, ocean's basically a frozen
nitrogen,
and you actually can see the flow, the convection cells.
Yes. Yeah. And in a little plug for Purdue, that pattern that they show of the polygons, the mechanics of that were worked out recently by some researchers at Purdue who came out with a paper on that.
And one other thing about Purdue is the number of astronauts that have gotten their education there.
That's right. I was attracted by that. A large number of astronauts came through Purdue, and Neil Armstrong attended Purdue. They have dedicated a new building for Aero and Astro in his name.
I see. Wow. All right. What age group of students have you been performing or lecturing for?
I have been aiming at about 1st grade through 7th grade. And that's an interesting question, because when people see my music online, or they see this CD listed on either CD Baby or on Amazon or iTunes, wherever, it's under a category called children's. Well, children's music is often designed for children that are younger than that, say up to 6 or 7, because they're trying to get the children to become
toddlers, really.
Toddlers learning how to move to a beat, how to coordinate their movements, and it's a very important thing. And I would say it's the primary application of children's music. So when I've written songs that are for elementary age, that's older, and there is no separate category for that. So sometimes people look at this and expect
big category of family/kids.
It is, yes. As I like to say, there's a big gap between Barney and Nirvana, and that's that's where I'm aiming. So there doesn't seem to be a lot of other material for that particular range of ages, but it is, again, categorized as children's in the various places online.
All right, outstanding. You have your guitar with you?
I do.
Would you like to perform for us?
I'd be happy to do a couple of songs.
All right, let's do that.
This song is called "The Stars Go By." Once we went into space to be part of a race so that people could walk on the moon. Many years have gone by, but again we will fly and return to the sky sometime soon. Can a girl fly through space to a planet? Could she pilot her spaceship and land it? Could she fly through the sky as the stars go by and bring home a space pomegranate? Many robots have flown to the greatest unknown and explored all the worlds of our sun. They have learned many things and gone through Saturn's rings, but there's so much that they haven't done. Can a boy fly through space in a rocket? Could he learn how to steer and to dock it? Could he fly through the sky as the stars go by and keep meteors in his pocket? You could learn to fly as the stars go by and reach for the endless sky. When the sun starts to sigh, many atoms will fly to be caught by the earth and remain. Glowing curtains of light will extend out of sight, painting colors that fall like the rain. Can the kids of the earth catch auroras? Could they have names like Tommy or Laura? Could they fly through the sky as the stars go by and hold northern lights in fedoras? You could learn to fly as the stars go by and reach for the endless sky. There's a world that's nearby with a red-colored sky and some others with ice all around. Some are big balls of gas where you'll never see grass since they don't really have any ground. Can the kids of the earth reach the heavens? Could they answer the biggest of questions? Could they fly through the sky as the stars go by and reach for new worlds as they beckon? Could they fly through the sky as the stars go by and reach for new worlds as they beckon? This next song is called To Follow Apollo, and it's the title track from my new CD. Long ago we flew the lunar missions to explore. Since that one small step we haven't been there anymore. Robots fly out to the moon and circle round and round. But kids could land their spaceships there and walk upon the ground. To follow Apollo around the moon they flew, to find some reminders of spaceships and their crew. Tommy did a survey of the landing sites of old. Laura found some clues by reading stories that were told. They began to make a plan to visit landing sites and see the famous places all before the lunar night. To follow Apollo around the moon they flew, to find some reminders of spaceships and their crew. Astronauts went to the moon and landed there 6 times. Every place was different, they found rocks of many kinds. There were 3 more missions planned, but never got to fly. So now the kids could finish what Apollo dared to try. To follow Apollo around the moon they flew, to find some reminders of spaceships and their crew. They came in peace for all mankind and made their mark for kids to find. First they found 6 places where some history was made. Looking from a distance, they could see the way things stayed. Then they planted flags in 3 more places on the moon and finished for Apollo what had ended far too soon. To follow Apollo around the moon they flew, to find some reminders of spaceships and their crew. This song is called The Little Bear. On one clear and cloudless night, stars were shining oh so bright. Kids went out to look up at the sky. They saw creatures great and small, then began to name them all. One looked like a horse with wings to fly. They saw the constellations with their imaginations and used the brightest stars that they could see. The North Star showed the little bear. They searched across the sky from there to find where other animals could be. High above the little bear, eagles soared up in the air. Tommy saw a bull with starry eyes. Down below a dragon slept, snakes upon their bellies crept. Laura saw a goat climb up a rise. They saw the constellations with their imaginations and used the brightest stars that they could see. The North Star showed the little bear. They searched across the sky from there to find where other animals could be. Out in front of Little Bear, they saw lions lying there, one beside another in a row. Ponies ran behind the bear, fish were swimming in a pair, rams were charging up a mountain slope. We can see the pictures in the sky if we use the twinkle in our eyes. Tall giraffes went striding by, lynxes leapt up in the sky. Laura saw the dogs begin to run. When the sun began to rise, creatures faded from their eyes. Tommy said that was a lot of fun. They saw the constellations with their imaginations and used the brightest stars that they could see. The North Star showed the little bear. They searched across the sky from there to find where other animals could be. The North Star showed the little bear. They searched across the sky from there to find where other animals could be.
That was Jim Thorne singing 3 of the songs on his CD, To Follow Apollo, Songs About Kids in Space. Thank you for joining us at Around Space, and see you next time.